When considering conversion, there are some things that an OEM should look for in a company that converts components to RoHS compliance. 1. What testing is done to ensure RoHS compliance? Is there a step in the process for conversion that removes the restricted elements from the device? 2. What standards are used to convert the components? Are there widely accepted standards used in the processes at the company? Is there an accreditation or outside certification? 3. There needs to be sufficient data that verifies that the process does not affect the functionality of the components. Look for results that cover electrical, pulse strength, and reliability testing. First, let's look at methods for assuring that the process converts components to RoHS compliant levels. The first step begins with investigation of the part itself. Is there a possibility of lead or other RoHS restricted element contained anywhere in the component other than the solder on the termination leads? A semiconductor package contains many homogeneous materials, which include the plastic molding material, tin electroplating coatings on the lead frame alloy, and the gold bonding wires. For many components, knowledge of where the restricted substances are likely to be found simplifies the analysis process. In a semiconductor package, for example, the only location where a restricted substance is likely to be present is the lead in the tin-plated termination coating. This can be analyzed using EDXRF. Cadmium may be used in the inks to mark components, but this is very unusual. Next, what methods of testing are done by the preconditioning service provider to ensure that the converted components are RoHS compliant? There should be some screening done to verify that the particular batches of parts were converted successfully. The most common screening method is XRF. For accurate testing within the 1,000 parts per million limit set by RoHS, extra steps need to be taken to ensure that the XRF test is properly calibrated. The screening lab should have SOPs that ensure repeatability and reliable results, and preferably be accredited by an organization such as A2LA. There should be SOPs that investigate and confirm that parts were converted to the correct solder type and that a removal of restricted elements was done prior to conversion. This removal of lead prior to the conversion process is vital, as XRF screening may not detect lead contained in the layer beneath the new solder coating. A converted part without removal of the original lead solder may pass XRF, but fail destructive testing for lead. Some preconditioning companies do not apply a qualified stripping process, yet still claim RoHS compliance. Beware of any conversion company that has not had destructive testing performed on the parts that have been through their process.